Hello, my name is Nick Ronconi from Applied Tech Systems. I really appreciate everybody attending today. The focus of the webinar today are possible solutions for two issues that many OEMs and suppliers are facing today. As manufacturers are continually driving lot sizes to smaller quantities, both OEMs and suppliers are facing increased documentation and traceability requirements. In order to respond to quality issues, the question becomes, one, how do I serialize my parts? And two, how do I digitize my quality data and trace that data back to the individual serialized unit level? This is especially challenging in paint and finishing processes where unit ID may be painted over and a label must survive harsh temperatures such as an oven or other environmental stresses. So today, Doug Stubbs from the Schreiner ProTech company will provide an overview of some innovative labeling solutions for finishing applications. After that, I'll give a brief demonstration of our ATS Inspect software that is in use in many paint operations for recording and reporting out on your paint quality data. Also, at the end of today's meeting, we'll have a question and answer period where you can answer questions. And then lastly, material will be sent out to attendees following the webinar. So at this point, I'm going to turn it over to Doug Stubbs from Schreiner ProTech.
Perfect. Thank you, Nick.
Thank you.
As my screen is visible, I'm hoping.
It is.
Perfect. All right. As Nick said, we appreciate everyone's time this morning. The next 30 minutes hopefully will be a very good use of everyone's time, and you'll learn a lot on this particular applications here. What we're going to focus on in particular, my part of it, is the individual serialization or track and tracing of individual parts in these extreme environments here. Let me get this out of the way. So, as everyone knows, the requirements for individual product tracking, tracing, and identification are growing exponentially in the manufacturing arenas. This is taking place throughout entire supply chains, but certainly throughout entire manufacturing processes. It is not unusual now to have to track an individual part from the moment it arrives on your receiving dock all the way until it's on your outbound shipping dock nowadays. So these requirements typically have been, let's say, harsh environments have been exempt from some of this, but nowadays that's not the case. Particularly in automotive and heavier type industries, individual traceability for the entire journey is required almost always. In paints and finishing processes, there are really two consistent challenges to tracking a part through the entire process: readability of the individual part, and then of course, temperature. So we'll look at a handful of technologies and how they stack up against these two obstacles. Come on. All right. When we talk about labeling, nowadays, we'll start at the bottom of the food chain, basically. Traditional labels are absolutely suitable for these types of applications in terms of how they handle temperature or can tolerate these extreme temperatures. This obstacle has been overcome. Standard industrial labeling materials are PETs that are good for typically 300 degrees Fahrenheit and higher. And there are even specialty materials that can withstand 400C or 750F. So the materials themselves, including adhesives and inks, are available to handle the temperatures involved in finishing operations. So in terms of traditional labels, the big challenge, of course, is readability. That is the problem. If you are painting over a label, you are obscuring the information and basically rendering it useless there. QR codes, barcodes, all the fine print can become illegible. And even if you're doing a clear coat type of operation, that clear coat can blur the printing and the codes to the extent that it even disrupts high quality vision systems, and again, renders the part label useless at this point. Worst case, of course, is that the data of that label is permanently obscured or even lost, depending on the extent of the coating or the covering up of the information on the label. Masking is a possible solution there on a traditional label here. So when we talk about a label with an integrated paint mask, it's different from the kind of masking you do if you're doing a home improvement projects here. These are one-piece or multi-layer assemblies here, where the mask itself is the removable overlay from the actual information on the label itself here. These masks and the labels themselves are resistant or designed for painting and high temperature type applications. So the full data, once you remove the mask, is available, it's preserved, it is undamaged. These particular kinds of products are easy to produce, very easy to apply onto individual parts, and as well, naturally remove the paint mask itself. An additional benefit is it is on the lower end of the cost and the sophistication scope here. So here's a look at how these paint masks are actually used in a painting type application here. At this point, it's just the coating of an individual label here. In a non-automated scenario, these are, you could manually apply individual pre-cut labels onto particular parts. This label has the paint mask on the top of it here, as you will see in just a second. There are a number of different methods for actually removing paint masks here, but as you can tell, a properly designed label and paint mask is easy to use, and the information is uniquely preserved for that environment as well. A second category of a traditional label type solution for paint and finishing applications are laser etchable films. These are actual labels similar to what we saw previously, but they are extremely rugged. They are built with an adhesive backing on them as well to be applied just like we have seen here. These materials are resistant to many paints, all kinds of chemicals, as they are used throughout the automotive industry, including under the hood. So they must be resistant to those types of chemicals and environments there as well. And they're extremely abrasion resistant. They can handle temperatures of typical curing ovens up to, say, 250, with the ability to spike higher for limited amounts of time. And these laser films are typically an alternative to direct marking or etching onto the part. We've all seen lasers that are used for etching into the exact parts themselves. That can be difficult in a paint environment because if too much paint is applied, i.e. it's too thick, you can cover up key information in that etched area there here. That is not the case with a laser etchable film here. As a bonus, these products use standard industrial lasers that many clients already have installed in their plants today. There are two primary categories of these laser etchable films, the most common of which is known as a laser ablation film. When you're ablating a substrate or a surface, you're actually burning away a top layer. So in the pictures on the right-hand side, these multiple layer products will have two different colors that are visible from the top here. In this instance, you have a black layer which is burned away, exposing the white layer underneath. So in the little graphic on the top, you're burning away, let's say, a gray layer to expose the red printing underneath here. When that is burned away on an ablation film, that material has to go somewhere and it just becomes smoke. It generates fumes here. The second category in a very similar type product is known as a color laser film. It is functionally and structurally very similar to a typical ablation film, but the primary difference is that it includes an over laminate on the very top, a layer right here that is not harmed by the laser itself. So the laser passes through this over laminate, it goes through and removes the black layer, exposing the white underneath here. One big benefit of a color laser film is that that laminate seals in any smoke or residue that would be discharged during the printing operation. And if these parts are either pre-cut into individual labels or cut mechanically, then there is no exhaust whatsoever here. of that kind of a product. So I'll take just 1 second to show what that kind of a product, be it an ablation or a laser film, actually looks like in use. This is a family automotive sheet, and these are real time. This is the speed with which these kinds of labels can be made with this kind of a material here. It is always fascinating to see the speed of these technologies and how they can be incorporated into the manufacturing process here. And as we saw earlier, it is very easy to put an integral paint mask onto these kinds of products for paint and finishing type applications here. The third and final technology appropriate for these applications is RFID. Everyone knows that RFID is by far the fastest growing technology in terms of individual part identification, tracking, and tracing here. RFID, as you know, is a remote automated data capture technology that has been in use for almost 40 years now here. And one of the huge benefits is it integrates seamlessly into your ERP, MES, and quality type systems here. It is a wonderfully flexible technology that can do pretty much what you want to. Your considerations for finishing and painting type applications come primarily down to the label or the tag that you're putting onto the part that needs to be traced and serialized here. There are really two form factors: traditional labels, similar to what we've just spent a few moments looking at, adhesive backed, having industrial label stock materials on them. These handle the temperatures of up to perhaps 450 degrees for a curing cycle, or 2 or 3 of them as well. Mechanical tags, as they are called, are very different construction. They can be adhesive backed, but they take many different form factors and typically require mechanical fastening onto the part that you wish to track or trace. They are very durable compared to a label itself, and with these variety of constructions available, you can have extreme temperature resistance all the way up to, in certain cases, up to 750 F. Definitely much different than you would get from a label itself here. So temperature is not a problem, but you do have the same limitations, let's say, potentially, as far as local readability once you are putting paint onto either a tag or a label itself. However, if you were to paint over an RFID tag or label, it's going to impact what you can see, just like everything else here. But the automated functioning or the data collection is absolutely unaffected here. So the functionality of the tag, if you're going with RFID, you typically are not worried about visibly looking at the tag because the data is available throughout the normal RFID frequencies here. So it is important to note, though, if you needed a combination, you can have RFID labels with masks on them, like we have already seen. That is absolutely doable. So in summary, it is, if you compare traditional labels with the rugged etchables with the RFID, all of them are paint resistant and suitable in those applications here. Masks can be an option on anything that is a label-based type of product. They have good heat resistance. The manual data collection with the masks in place is available. Remote data collection is, of course, reserved for the RFID application only. And all of these can be cost effective with acceptance going up. Industry costs are coming all the way down here. So it is absolutely possible to track and trace your individual parts throughout your paint type applications. Options at all levels of sophistication are absolutely available to you as well. So I will turn this back over to Mr. Ron Coney, who's going to talk about bringing these individual traceable parts now into system-wide quality improvements. Mr. Ron Coney.
All right. Thank you very much, Doug. I appreciate it. Well, now that we've explored some options for serializing parts, let's look at ways to actually digitize and improve our quality-related data, as Doug just mentioned. There are usually quite a few inspection points throughout a finishing or paint process, There are quality gates set up where, in my experience, a couple different types of data are collected, generally on either paper forms like you see presented here now, or through homegrown applications or Excel spreadsheets. So the two types of data basically take the form of an inspector looking at a product and noting visible defects, such as overspray, sag, orange peel, drips, etc. So a typical form would look like the one you see on the upper right-hand corner here, where an inspector will note both the location and the type of defect, and there's one sheet per product. Then all of these sheets are usually handed to somebody who then takes the individual results, plots those on a master sheet in order to get actionable information, such as a defect map over a series of units created in a shift or something along those lines. The other type of data that's collected are what I would call checklist. You see two examples of this on the left. There are a lot of product property type measurements taken for things like gloss, distinctness of image, or mill checks for the thickness of paint. So that one you see on the upper left is where someone's taking mill checks on a boat trailer that's been painted. Also, there's generally someone who might go around and audit process or environmental type parameters such as temperature, humidity, etc. So there's a lot of both visual defect tracking and there's quite a bit of checklist type data collection going on. So there should be a better way to do this because, well, if you're going to serialize your parts with labels and RFID tags, you can't interface those to a piece of paper. There's also, of course, a time lag whenever you're using paper because in order to get actionable reporting, you have to take those sheets of paper and key it into something else. So what I'm going to be showing you here today briefly is our ATS Inspect software. Inspect is an off-the-shelf modular software package that can be run on either a tablet or a fixed station PC. What you're looking at now is the screen of the data collection interface. And a couple things I want to point out. This is a configurable software. There are tabs for operator or inspector navigation across the top. I'm going to select a unit here to inspect. In my example, I'm going to be looking at a car that we've called the Bongo. So I can select it using a pick from list, but if you are using a barcode label RFID tag, the unit and product can be pulled up automatically as well. And then you can start your inspection after the product has been called up on your screen. All right. I'll also call your attention to the fact that up here, you can see that there's a serial number window. So again, if you're pulling into a station, one of the advantages of using software is I can scan that barcode or read the RFID tag and we'll capture the serial number. Subsequently, any data that we are collecting at any of the quality gates on that serialized unit will all be stitched together into a digital record and all traceable back to this serial number. I'll also mention that you can capture child and parent part relationships. So you can say capture an airbag serial number, or if you're assembling boats, for example, you can serialize the hull and the deck and then tie both of those back to a boat unit serial number as well. So first we're going to do some visual data collection. You can see here, I see an image of our Bongo car. It is a live CAD image. I can grab it and rotate it, enable to orient it to the position I want to log a defect. We also have what we call thumbnails over here on the right-hand side. So by clicking on these thumbnails, it will orient and zoom in my CAD image to the exact rotation and surface area that I want to log my defect on. So first we'll collect some simple defects. I can do this as an inspector by simply touching the location on my part image where I see a defect. In its simplest application, I then am presented with a list of possible defects in my own vocabulary that I want to be able to choose from. You'll also notice some job aid and work instruction options for you. I can have a thumbnail of the job aid on the actual button itself. You'll see here, I have an icon that says there is a document associated with this crater defect. I can simply click on that and then I can access a job aid, a standards document, work instructions, etc. For that. Also over here on the left, you can have things such as job aids and work instructions, which can be PDFs, they can be videos, Word documents, etc. So again, if you have an inspector that needs to look at a standards document, you can make those available quite easily versus having a paper version of those out at your station. So if I'm an inspector and at that location, which I've noted, I see contamination, I simply touch contamination. It can be that simple. You'll now know that we have logged both the location and the type of defect. I see a flag on the screen that notes the type of defect, so anyone looking at this record can easily see what the defect is and where it is. The flag here, as we call it, is also red because that has not been repaired yet. I can continue on and add multiple defects. So if I see a different type of defect here, like a scratch, I can enter that. And again, it could be that simple, but many times in a painting or finishing operation, I want to add other details or collaborative information. So for example, here I can say what size the scratch is. If you rank your defects and want to sort by rank later, you can say what a rank is. We also have the concept of responsible cell and area. For example, in a paint application, generally you're also finding substrate defects. So in this example, I see a scratch on the part, but that might have been on the metal stamping. So I'm actually going to assign that defect responsible area as stamping. And then later on, I can sort by substrate versus paint defects. A couple of other important things when I'm doing an inspection for paint is you might want to add comments. So for example, I can click on this icon and I can add a comment such as new carriers, wish I could type better, produce more scratches, or any other thing you would like to note. I can also take a photo. So for example, here if I click on the photo icon, I can now access the camera that's usually integrated into my tablet or an external Bluetooth camera. So all I have to do is press this plus key. I don't have a car, so I'm taking a picture of myself as the defect. And you'll see that that image is now associated with that exact defect on that exact unit. It's time and date stamped. We know who took it, etc. So again, I save that, and you can start to see that we're building a record of all of the inspection information associated with this vehicle. So that's one type of interface, is what's used to log defects against an image of my painted product. There's also that checklist type interface. A checklist is just what it sounds like. There's a series of items that you would wish your inspector to respond to. Here it's asking me to master the alcometer before I take my mill checks. At any point in time, just like I could during visual inspection, I can call up the job aid or work instruction. I can say, yes, I mastered it. Now I'm going to do 3 checks, and you'll see as I go through the check, there's a job aid that changes and shows the inspector exactly where the measurement should be taken. Now, if I have a digital gauge like an alcometer with an output, the software will take that reading directly, or you can type it in as I'm doing now. The software compares the value to your spec limits. So you can see here my reading of 13 mils is way too thick. It gives me a customized message, and we've logged that as a non-conformance up against your product. I'll just finish up my mill check here. And then lastly, you can just do confirmations such as, is the masking correct? So here I've taken both a visual defect and a checklist type example and show what that looks like in our inspect data collection module. All this data is immediately transferred to a non-proprietary MS SQL database, which now I'm going to access through my browser. So you should be seeing a screen that says ATS Advanced Reporting Services. This out of the box has over 80 different reports that we can use to mine our data. If I look on the left-hand side, you see a listing of those reports. They're organized by category. And the way this works is I select the report I want. In this case, I'm going to take a single unit history. Then based on the report I choose, I get a series of filter criteria over on the right where I can sort by shift, or in my case, I'm going to put in a serial number for the unit that I need information on, and then I run the report. So when that report renders, what I'm going to start with here is this single unit history. So as I mentioned, if you have several different quality gates throughout your process, Inspect will take all of that information and tie it together in a single unit history. So you can see here I've captured the serial number by either scanning a barcode or an RFID label. If I had some child parts here, they would all appear under these IDs. And as I scroll down, you get some very valuable information that's all available at a moment's notice. I can see how many inspections took place, and if I was repairing this part, I would also see the repairs. I can see how many minutes it took to do that process step. I can see what shift it's on, what station it was taken on, like the paint hospital, the spill out deck, final assembly, who the user was, how many defects there were, etc. As I scroll down, the software reveals to me a snip of that CAD image, and it notes where the defects were. They're color coded. The green indicates that that defect was repaired. The red indicates it is unrepaired. As I scroll down, I can get even more information on each one of those defects. For example, here, I see that for the contamination, we have a comment where it says we seem to experience more contamination after changing colors. You'll also notice that in this image column, there is a link to a number 1. And by clicking on that, I can see the photo that was taken that the inspector associated with that defect. So everything is available here for each unit. And again, it's all tied back to serialization. So you can see by serializing your painted parts and the methods that Doug has presented, and then digitizing your quality data and leveraging that traceability, you really get a leg up on being able to know exactly what happened in your processes. So there's 80 different reports. You saw that single unit history, but also all of the data for every inspection is in the database. And then you can get what I call aggregate reports. So I've pre-done some reports here just to show you, you can break down your defects by hour. So in a paint application, it's pretty valuable to find out, hey, do I have something that gets worse based on the time of day? So here I can see my pinholes, for some reason, are more popular at this hour of the day than it is at a different hour of the day. Other defects you can get, or reports you can get, excuse me, is you can trend your defects. You can rank defects by product, so you can see which product is producing the most defects. You can get things such as Pareto charts of your various defects. And all of these reports have drill downs. So for example, if I just ran a report that said, what were my biggest defects through the paint shop this week, and I see pinholes as the biggest problem, I can then click on that bar on the report, and it will then show me which panel, for example, on that bongo car has the most pinholes. It does actually get better than that. And what I mean by that is, since we are capturing both the location and the type of defect, you can instantly get scatter diagrams and concentration diagrams of your defect on the vehicle that or part that you're producing. So for example, here we're looking at a concern scatter. So for the current week, I've asked the software to plot all of the different paint defects against my CAD image. I can either look at just one individual defect, or as I've selected here, I can see all of my defects plotted against that image. So I can just see, for example, sags, and I can add scratches, or again, I can say I want to see all my defects and they're instantly plotted against that CAD image. Another common report that's used in many paint facilities is by laying a grid over your product. So here you can see I've laid a 10 by 10 grid over the product. The circle inside each quadrant here tells me by color code which one is my worst performing quadrant based on the highest percentage of defects found in that quadrant. You'll also see there were 9 units that had that defect. If I click on that, I'm instantly presented with a list of the individual serialized units that have that defect. So if I need to run a containment exercise, it's very easy to do so. I can also make the grid more granular. Here I'm going to change it to a 15 by 15 grid. And as we've also discussed, I can always change the orientation of the CAD image, and the report updates instantly. All right, so that's a quick rundown of the software, both the reporting and the data collection portion. That brings us to the end of our webinar. So at this point, if you have any questions, please type those questions into your chat box and Olga will read them. Also, just a reminder that after the webinar is completed, Doug and I will send out some supporting material for you to have as a reference. All right, thank you for attending. I appreciate it. Olga, do we have any questions at this point?
Yeah, hello, Nick. Yeah, we have a couple of questions. Let me read those. So is it possible to have multiple masks that can be removed at different times on a single label?
Yes, that's absolutely possible. We're seeing that in applications where, let's say, there's a transfer of a part between a vendor to a next stage vendor. It may be that the first phase needs to do some sort of coding or process where a mask is appropriate. They can then remove that mask, have fresh data, And if that remaining label has a mask already, it's already ready to go for the next coating type of process. So multiple masks are a standard option, yes.
Okay, thank you, Doug. And another question, I think this is for you, Nick. Is it possible to interface the Inspect software with other systems, such as SAP?
Yeah, good question. Yes, is a short answer. So many companies implement Inspect as a standalone solution, and the data is kept just within our database. But in many cases, there's an ERP system, like you mentioned, SAP, or other ERP or MES systems such as Plex, Siemens, etc. And folks would like data to be transferred into those systems, so any defective product or other information collected in Inspect can be transferred to their ERP or MES system. So I'd say in about 80% of our installations, we've actually done some integration to send data or receive data from an ERP, an MES, or a scheduling system. Inspect has a comms module specifically, which is intended to exactly facilitate that type of communication. So it's not only possible, but it's pretty common as well. Thank you, Olga.
So in that case, that's all. So thank you, Nick and Doug. And I think we can close the session.
All right. Thank you. And I'd like to thank everyone again for attending today.
Thank you all.
Thank you. Bye.